Hello everyone! Today we are going to be working on systems again, but this time with application. I'm going to start off by writing a list of steps. Wow, that sounded weird. Steps and hints. You've done this before back in Algebra 1 when you learned it for the first time, and in Algebra 2, I believe. So the first thing I think you should always do is define your variables. Usually the easiest way to do this is to look at the equation. I don't know why I said equation. Look at the question. The question is usually asking you to solve for one of the variables, so that can kind of help you define them. And you need to make sure you're being specific. Is it the number of? Is it the cost of? Whatever. Then write down your equations. This is the hardest part. When you're writing your equations, it's important that you put something down so that it makes sense. And when I say that, I mean, a lot of students struggle because they don't just try to come up with an equation. Just try to come up with something and then read it back to yourself and see if it actually makes sense. But you need to put something down. You need one equation per variable. That doesn't mean it's only one variable in each equation. It's just if you have two variables, then you should have at least two. You should have two equations. Then solve using regular stuff. So set up your matrices. Use your graphing calculator, unless it tells use do by hand. And then you need to write your answer in a sentence. And this is going to sound so silly. Answer the question. Make sure you're reading the question and answering the question. I've had students who don't actually answer the question. They answer what they think the question is asking. So we're going to do two examples in this video, practicing this. If you feel like you don't need to watch the rest, then don't. But make sure you're showing your work and writing your final answer in a sentence. So here's the first question we're going to do. Superman buys 4 hot dogs, 2 slices of pizza, and 5 sodas for $26.73. Batman buys 4 hot dogs and 7 slices of pizza for $37.93. And Iron Man buys 3 hot dogs, 1 slice of pizza, and 4 sodas for $18.49. Write and solve a matrix equation to find the cost of 1 hot dog, 1 slice of pizza, and 1 soda. Okay, so first things first, define your variables, and looking at the equation is going to help you. So what do we want to find? The cost of a hot dog, a slice of pizza, and 1 soda. So there you kind of go. You can call them X, Y, and Z. Why don't we do H, P, and S? So I'm going to say H is going to be the cost of hot dogs, or cost of 1 hot dog. What did I say? P for pizza. Cost of 1 pizza slice. And S for 1, or cost of soda. Okay, now we need to write equations. So this one's actually pretty easy, I would say. Superman's buying 4 hot dogs, 2 slices of pizza, and 5 sodas. Actually, it might be easier just because I'm so used to them. I could see people trying to define their variables as Superman, Batman, and Iron Man, but it doesn't really make any sense. How could you write an equation about Superman as a variable, right? 4 Supermans equals what? So we can use it though using hot dogs, number of pizza slices, and sodas. So Superman is buying 4 hot dogs plus 2 slices of pizza plus 5 sodas, and he's spending $26.73. And then read it back and doesn't make sense. So 4 is just a number. We need it to become money, and we're doing that because of the cost. So it's 4 times the cost will tell us the total price for the hot dogs. And then we do the same thing. Batman is also buying 4 hot dogs, 7 slices of pizza, and doesn't look like he's getting any soda, so I'm gonna just put a 0 here. That's how I am too. I'm like Batman, I don't usually get a soda. Drink my water. I'm already eating a ton of junk. Okay, Iron Man. 3 hot dogs, 1 slice of pizza, and 4 sodas. Why are they buying so much soda? Well, it's a math problem. And then you're going to solve this using matrix multiplication in your system. So set up your AX equals B, do the inverse, and solve. If you want to do this, go for it. I'm not going to do it so I can make this video as short as possible, but I'll tell you the answers. The number or the cost for hot dogs is $2.50. The cost for a slice of pizza is $3.99. And the cost of soda is $1.75. And if you'd like to solve it, or if you have issues, then come to flex time. Alright, here's a second problem that's a little bit trickier. A theater has tickets at $6 for adults, $3.50 for students, and $2.50 for children under 12. A total of 278 tickets were sold for one showing, with a total revenue of $1,300. If the number of adult tickets sold was 10 less than twice the number of student tickets, how many of each type of ticket were sold for the showing? So again, we needed to define our variables, and looking at the question helps you. How many of each type of ticket were sold for the showing? So there we go. We can have A for adult. So number of adult tickets. And it's sold, right? S is student. Number of student tickets sold. And what was the last one? Children. Okay, so there are my 3 variables. Now we need to figure out our equations. So this one's tricky because, like in our last example, they're all kind of following the exact same flow, I guess, or order, right? How much each person is buying, and then it equals the cost. This one you have to really read the problem. So the theater has tickets at $6 for adults, $3.50 for students, and $2.50 for children. Okay, well, I mean, that's the start of a problem. So $6 for an adult ticket, $3.50 for a student ticket, and $2.50 for a child's ticket. But what would that equal? Hopefully you're thinking money, right? Cost per adult, cost per student, and we had a total revenue of $1,300. So there's one equation. another equation. I'm going to use another pen. So we know a total of 278 tickets were sold. Okay, well, A is number of adults, S is number of student, and C is number of children. So that just means when we add all these together, we have a total of 278 tickets, right? Tickets plus tickets plus tickets gives you more tickets, just like money per ticket plus money per ticket is going to give you money. And then the last one, it gets kind of interesting. Where is it? If the number of adult tickets sold was 10 less than twice the number of student tickets. Okay, so the number of adult tickets sold equals 10 less than, so that means we're subtracting 10 from something, and it's less than twice the number of student tickets, so that's just 2 times the amount of student tickets, and there's my third equation. So I have to do some rearranging for my third equation in order to get it in the right order for my matrices, but that's it. Like I said, you can read it back. So adult ticket is twice the amount of students minus 10. Well, that fits what I've highlighted in pink. So, like I said, this is the hardest part, but defining your variables is the first step, and then writing your equations, and really you just got to try to put something down. If you think it makes sense, whether it does or doesn't, but try to put something down, and usually reading it back to you will help. If you have any questions, come to Flex Time.